All right, students, we'll go over um, problems from this worksheet. The whole front side, I'll do a couple of them, are all solving proportions. Okay? Proportion, remember, is a ratio that equals a ratio. Okay? Uh, so we're going to do them all the same way, so I'm not going to do any of these easy ones. Okay, it's the same steps for each one. Let's pick one in this middle section here. For example, we'll do 14. Okay? How do we solve all proportions? Well, first off, when I have a ratio and another ratio, I have to make sure and ask myself, is there more than one term in the numerator or denominator? If there is, I need to have parentheses around it. So I need parentheses around this one right here to make sure I distribute through it. And then how do I solve all proportions? Cross multiply, set equal to each other. So I'm going to cross multiply and set equal to each other. 18 equals 7 times x minus 2, quantity x minus 2. Distributive property. Now I could have divided each side by 7, but 7 does not divide into 18 evenly, so there's no reason to do that. I'm dealing with fractions anyway. So I'm going to go ahead and distribute, and I get 7x minus 14 equals 18. Add the 14 across, and I get 32. And last step, divide by 7 on both sides, and I get x equals 32 sevenths. And there's your answer. If that simplified, I would need to simplify or reduce it. It does not, so I'm done. Okay, so that one only had one parentheses to put around it because I only had one numerator denominator with two terms in it, two or more terms. Let's pick one where you have two. Let's go ahead and do 23. So I have two terms there, so I need parentheses around it. I have two terms there, so I need parentheses around it. And again, cross multiply, set equal to each other. So I get 2 times the quantity x minus 1 equals 3 times the quantity x plus 1. Distributive property, 2x minus 2 equals 3x plus 3. Let's change the color now. Okay, and remember I always want to bring the smaller number of variables to the bigger side, so I end up with a positive. So 3x minus 2x is 1x, which means I'm moving the constant to the other side, subtracting 3 from both sides. Negative 2 minus 3 is negative 5. If I want to guarantee I'm right, I can check it by plugging negative 5 back into there. Negative 5 plus 1 is negative 4. Over negative 5 minus 1 is negative 6. And negative by negative is positive. And 4 6 reduces to 2/3, as it says right there. So I'm guaranteed I have it right. Okay, so that's every problem on this page. Other side now, SohCahToa. Okay, so it says for each triangle, find the sine of n. Remember, SohCahToa. Sine equals opposite over hypotenuse. That's your sine equals opposite over hypotenuse, O and H. Cosine equals adjacent over hypotenuse. That's how we just simplify adjacent and hypotenuse. So here's your O over H, here's your A over H, and lastly, tangent equals opposite over adjacent, which is your O over A, and that's how we get our SohCahToa. So the capital letters are the trig functions themselves, and the lowercase are the ratio for that trig function. So sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent opposite over adjacent. So it says for each triangle, find the sine, cosine, and tangent to the nearest thousandth. So that means they don't want you to leave it as a fraction. They want you to go ahead and put in your calculator and give it as a decimal. Okay, notice this says sine of n. So that's the vertex that we are using, or where we can also put what's called theta right there, angle n. So the first thing I want to do is identify the hypotenuse. The hypotenuse, remember, is always across from the right angle. There's my h for hypotenuse, and then opposite and adjacent. Remember, adjacent means next to. So there's my h, o, and a, and now I can just fill in the numbers. So I need to do it for both sine, cosine, and tangent. We're just going to do a number 1 here. Let's go ahead and change the color. Okay, so sine of n equals opposite, which is 10, over the hypotenuse, 26. And so sine of n, they want you to just change it to a decimal. So you're going to go 10 divided by 26 in your calculator. 10 divided by 26. And you get that number, they want it to the nearest thousandth. So there's the thousands, tenths, hundredths, thousandths. So I look at the one right behind it. That's 5 or higher. So that's going to make that round up to a 5. So 0.385 would be my answer. 0.385. Okay, that's sine. Cosine of n is adjacent, 24 over 26. Put that in your calculator. 24 divided by 26. Okay, and notice it's 0.9230, so it's less than 5, so it stays 0.923. 0.923. And last we have tangent of n. Tangent is opposite over adjacent. 10, adjacent 10 over 24. Okay, put that in your calculator. 10 divided by 24. And it's 0.416. And since that's a 6 in the next spot over, remember I need to go ahead and round up. So 0.417 is the nearest thousandth. 0.417. Okay, so that's what you're going to do for each of these here in this top part. Next section says use a calculator to find the measure of each angle to the nearest degree. So we're solving for the angle itself. That means I need to get rid of the sine or the cosine or the tangent. Now, how you get rid of it is by doing the inverse. Inverse sine. Whatever I do to one side, I must do to the other side. Inverse sine. And that's on the button on your calculator. It's the button right above your sine. Right above sine would be inverse sine. How do you get that? You hit the second button up in the top left and then sine. Or use your graphing calculator. I'd have the color there for you. I think it's still second. Okay. But so angle A equals the inverse sine of 0.3779. Now what I do have to remember is my calculator needs to be in degrees. If you're using graphing calculator, the graphing calculator by default is in radians. So you must hit the mode button and go down. I see here 3 or 4 down where you see mode and degrees. I mean, you see radians and degrees, and change it over to switch over to degrees and hit the enter button if you're on the graphing calculator. Scientific calculator, you got to check to see. So that's the standard one. Can I switch? All right, let me close this one. Let me see if I can type in scientific calculator. Because I know it's got a scientific calculator here. Scientific calculator. Let's pin that. Oops. Oh, why is that bringing it up? Okay. Let me see if I just do calculator to begin with and see if I can change it from, oh, and I hit scientific down here. There we go. Okay. All right, so here's our inverse button right here. Now in this calculator, so if I hit inverse first, it's not going to do what we want to. And then if I did 0.3779, 0.3779, see, so sometimes scientific calculators, you have to do the decimal first and then inverse, which is what it is on this one. So 0.3779, and then I hit inverse sine. And notice I get 22.204. So 22.2 degrees is what it's in, because we are in degrees. Okay. You want to check the mode. Let's see if it shows it right there. See, it's showing you the degrees right there, but degrees what we're in already. Clear all this out. Where's my clear right here? So 0.3779 inverse sine, 22.2 degrees is my answer. What did it say to the nearest degree? So 22.2 is 22 degrees. We're going to the nearest degree. So 22 degrees. Okay. So you're just doing inverse sine or inverse cosine or inverse tangent of that decimal. All right. And lastly, for each triangle, find the measure of the marked acute angle to the nearest degree. So I need to recognize, again, hypotenuse, opposite, and adjacent. So the two that are given to me are the opposite and adjacent, and that is tangent. So that tells me to use tangent, and we'll just call it x. And so the question mark equals the opposite, which is 3, over the adjacent, which is 8. So remember how to get rid of tangent? Inverse tangent. So inverse tangent of 3/8. You can just put that in parentheses like that. And then nearest degree again, that we're going to. So it's approximately. So I'm going to go 3 divided by, bring up the calculator again. Okay, clear it. 3 divided by 8 equals that decimal. And then I hit inverse tangent. 9.5. Okay. So 9.5 degrees, which is going to round 9.53, which is going to round up to 10 degrees. So it's approximately 10 degrees. Which should then put this at 80 degrees, because remember they're complementary. So another way to check, let's say for example, so I'm saying that's 80 degrees. The tangent of 80 should be 8 divided by 3. So if I do tangent of 80, so 80 tangent is 5.67. So was I in the degrees here? If I do tangent of 10, let me try tangent of 10. 10 tangent. Do I have what my mode is here? I thought if I hit degrees, let me clear this. I'm in degrees. Okay. What was, all right, here, back here. Inverse tangent of 3/8, so 3 divided by 8. 3 divided by 8 equals that. Inverse tangent. Oh, inverse tangent. I must have hit tangent. Okay, 20.55 is 21 degrees. That's why it's off here then. Oops. 21 degrees. Okay, that's why this didn't work out when I was checking it. So that makes this 69 degrees, approximately. So if I do tangent of 69, 69 tangent, I get 2.6 approximately. And when I do 8 divided by 3, 8 divided by 3, notice I get 2.6 repeating bar. It's close to 2.6, so we did an estimate. So that shows that what I done made sense, because I then took the 69 to the tangent of that. Tangent of 69 is going to be opposite over hypotenuse, so that's 8 divided by 3. Okay, so I mustn't have hit inverse tangent or something like that on the first one. I did 3/8. But that is the correct answer at 21 degrees. Okay, 15 minutes.